if a parent function first is translated to the right by 3 units and then vertically up by 2 units, or if that same parent function is first translated vertically up by 2 units and then horizontally to the right by 3 units, would it make any difference if we switch the order first horizontally right and then vertically up, or first vertically up and then vertically right? Or if there was another parent function which we stretched and then we translated it vertically down, or if we switched the order and we first shifted it vertically down and then we stretched, would it make any difference in the order of transformations? Let's find out. So here we are with our graphing calculator. Let's just add a graph page. We're looking at a combination of transformations today. All right, so let's just use the square root function as our parent function. Remember, we're looking at not just a combination of transformations, but we're trying to explore would the order of transformations matter. All right, so we've seen in earlier videos about translations, about dilations. There are still some other videos we'd like to do on other kinds of transformations, but I thought maybe, let's try and see how we can combine, but not just combine. Let's just try and explore would the order of combinations matter. That's the subject of this video. All right, so this is my parent function, the square root function. Let's just bring it on. That's our parent function. And we said, let's just first, translate it to the right and then translate it up by, 3 and 4. Let's just check it out. All right, so my first step would be a translation to the right. So let me make it F1 of, let's move by 3 units. Okay, so x minus 3. All right, so F1 of x minus 3, the new graph, that's the first step. Okay, so there you go. The red graph is the first step. I'm just going to bring this thing here. That's the first step. Now, after moving 3 units to the right, let's take it up by 2 units. Okay, so the second stage, F3 is going to be F2 of x. All right, whatever that F2 of x is, remember F2 of x is already a transformation of F1 of x, plus we're taking it up by, let's say, 2 units. All right, so here we go. If I hit enter, that is a transformation of F2. Okay, so overall translation of F1, that's the parent function. First, it's gone right by 3 units, and then it's gone up by 2 units. Let's just make that green, okay? Because apparently green is my favorite color. That's the new transform graph, okay? Made up of 2 transformations, all right? Made up of a translation to the right first, and then translation up next, okay? So that's the final position of this original transformation function. Now, what we want to explore is, what if we change the order? First, we take it up, the blue graph, first we take it up by 2 units, and then we go right. Okay, let's just find out. Okay, so to do that, let me insert a new problem, all right? Okay, and do the same thing. So my parent function is still going to be the square root function. And here we go, all right? So that's the square root function. This time what I'm going to do is my second function, instead of going right first, we're going to go up first by the same units. Let's compare. That'll be good to compare, right? So we're going to call this one is going to be F1 of x. That was my function. And I'm going to take it up first, okay? So there we go, all right? That is my first level of transformation. Stage 1, the parent function has gone up by 2 units. Now, stage 2, this is going to be F2. And remember, we want to move the red graph across to the right, okay, horizontally right by 3 units. Let's just check that, okay? So x minus 3, and there is the position of the new one. And again, let's make it green. Let's make it green. That will help us compare, right? So here we go. I'm going to make that green. And so now, in order to compare the 2 graphs, the 2 green graphs, let's just compare that coordinates of that origin, all right? So the origin shifted from here to here to here. And here the origin shifted from here to here and then to here. Okay, so let's just do a comparison of the origin, all right? So here we go. If I say graph trace all, and so that every point can be compared here at 3, we're just comparing the green graph. Okay, the origin of the green is 3 comma 2. Can you see that? 3 comma 2. Okay, so that's the new transformed. Remember, this order was first to the right and then up by 2 units. Here, let's do the same thing here. Okay, so menu, trace, trace all, and 3 comma 2 again. 3 comma 2 again. So this one is also 3 comma 2. All right, this was first right and then up. And here we went up first by 2 units and then across by 3 units and still 3 comma 2. Okay, so that means order doesn't matter. Or are we jumping to a conclusion very soon? Let's try something else. Okay, let's try something else. So let me just insert another problem. And this time, let's keep the same parent function. Okay, this time let's mix it with a stretch. In the first case, what we compared was the combination of the transformations was both translation, translation horizontally and translation vertically. We took translation horizontally to the right and vertically up. Okay, but you can also try the same, maybe horizontally to the left and horizontally and vertically down. But this next stage that we are comparing the order of transformations is where we're taking a combination of two different transformations. Okay, maybe start with a dilation, okay, a vertical stretch, a stretch along the y-axis, and then a translation perhaps down. All right, so let's mix the transformation and try and explore what's going to happen. So let's say our vertical stretch factor is 2. So my second graph is going to be 2 times f1 of x. Okay, for those of you who haven't seen my video on dilations or transformations or any of the translations, I'll link those videos. Please go and take a look at it, how 2 times f1 of x or 2 times the original parent function is a vertical stretch, all right, along the y-axis. All those explanations are given in the video. Go and take a look at that. Okay, so here we go. That's a stretch along the y-axis. Okay, that's the first stage. Now we said that we want to move this graph down, all right, vertically down. So what I'm going to do is that next stage is going to be f2x, and let's just go down by 5. Okay, vertically down, and here we go. And that's the new graph. And again, let's make it what should we call it? A green color. All right, I don't know. Today's a green day for me. I should have been playing some Green Day music when I was saying this thing. Okay, that's just a cheesy joke. So here's my original function. Blue is the original parent function. Okay, a stretch of factor 2 along the y-axis. Okay, all right, there you go, dilation there. And then it's come down by 5 units. All right, so let's get that coordinates quickly first. So here we go, trace and trace all. And we can see that coordinates are that vertex that was 0, 0 here. And now it's come down to 0, -5. Okay. Let's change the order. So what we're going to do is that we're going to insert another problem, and starting with the original parent function, which is the square root function, we are going to first take it down by 5 units and then stretch that function. Okay, stretch by 2, a factor of 2 vertically, all right, along the y-axis. So here we go. Let me insert a new problem. And again, to keep things consistent, let's stick to the square root function. And that's my parent function there. This time, what we're going to do is that first take it down vertically down by 5 units, right? Is it 5 units here? Yeah, 5 units here. So let's just go and say we want f1x going down by 5 units, all right? So here we go. It's come down by 5 units. All right, I'm just bringing the label here. Now, we want to stretch that, okay? Vertical stretch, a dilation along the y-axis, all right? So insert, and remember what we said, it should be 2 times f2. That was the second thing, right? So f2, so f2 of x, okay? Don't blink, watch, don't blink. Aha, it went somewhere else. It went somewhere else. Let me just make that green color first, okay? Right click, color, line color, and green. All right, now notice, okay, notice this, okay? So what have we done? Let me just first get the coordinates, okay? Then you'll know. Menu, trace all, and no, that's not what we wanted. We wanted the origin, remember? Okay, there you go. Green graph, origin, can you see? 0, comma, negative 10, whereas green graph here is 0, comma, negative 5. Aha. In the first case, where both the transformations were translations, horizontal and vertical, we noticed that the order didn't matter whether we were going horizontal translation first and then vertical translation. But now when we mixed the transformations, with the translation and a dilation. So parent function was a square root function. The first one was a stretch vertically along the y-axis. And then we said, okay, going down by 5 units. The same operations, the same factor stretching by a factor of 2 vertically and vertically down, okay, a translation of going down by vertically down by 5 units, all right? When we change the order, we just notice, look at that was the parent, okay, the parent is there. First, we brought it down by 5 units, and then stretching that result by 2 units is not actually giving the same graph. And that means that order does matter when it comes to combined transformations. So far in the earlier videos, we were just looking at translation separately or dilation separately. But when you have a combined set of transformations, the order does matter. The order of the transformations does matter. So when we are going to look at curve sketching in the next video, I'm going to suggest an order of transformations so that even if you have to solve a question without the help of the calculator, follow the suggested order and your curve, the sketching that you do, will be correct. Don't miss that video, okay?